right, so we are going to switch gears again and cover polyatomic ions and polyatomic compounds, also known as ternary compounds because they have more than three or more elements in them. So objective number 6, apply the rules for naming and writing formulas for compounds containing polyatomic ions. So you're going to see compounds that are going to be between a metal and a polyatomic ion, or a polyatomic ion bonded to a nonmetal, or two polyatomic ions bonded together. How does naming a compound with more than two elements differ from naming a binary compound? That's kind of our essential question for today. So polyatomic compounds are special in that they contain, instead of being one element and another element bonded together, you have an element bonded to a polyatomic ion, which poly means many, atomic meaning atom. So there's more than two elements given here. But you will treat the polyatomic ion like it's one group. So it gets treated like it's one atom, even though it's not. The entire group is bunched together, and the charge goes with that whole group of elements. So there are negative and there are positive polyatomic ions. Most of them by far are negative. There's a few positive ones. And here's an example of a polyatomic ion. So PO4 with a 3- charge. This is not a compound. If it was a compound, you would just see PO4. You would not see the 3- charge on there. But because you see that 3- charge, this is now what's known as phosphate. Instead of being phosphorus tetraoxide, this whole group would be kept together as the phosphate ion, and the whole group has a 3- charge. You're going to be given a list of them. You will not have to memorize them. So here's a list that looks similar to the one you're going to get. This is not the exact one that you're going to get, but it's similar to it. So here's a positive one, ammonium, NH4 with a 1+ charge. So NH4, and because it has the 1+ charge on it, that makes it the polyatomic ion. Nitrate and nitrite, sulfite and sulfate, hydrogen sulfate. You notice all of these have charges on them, which is why they are called ions. These by themselves are not a compound. You might see compounds that are NO2, but it's not going to have NO2 with a 1- charge on it. So these are just some of the main ones: hydrogen phosphate, dihydrogen phosphate, carbonate, hydrogen carbonate, hypochlorite, chlorite, chlorate, perchlorate, acetate, permanganate, dichromate, chromate, peroxide. Like I said, I will give you a chart very similar to this. And you'll notice on here there's actually only one that's positive. There's another one that's positive, the hydronium ion, which is H3O with 1+ charge, and that'll be on the chart that I give you. Okay, so you guys are going to do some discussion questions. So what I want you to do is leave a spot for 1, 2, and 3. You can just leave 1 line or 2 lines for each of these. So just leave 2 lines underneath the beginnings of polyatomic ion for your discussion questions, and this is what you guys are going to discuss in small groups. All right, so now back to your actual notes. These ions, like I said before, they will combine with other elements, but you're going to treat them like they are one group, and that's because the charge goes with the group. So there's 3 types of compounds that we tend to see with polyatomic ions. We see a metal bonded to a polyatomic ion. And in this case, you have a positive bonded to a negative. So just like before, we balance charges. You still use the stock system for your type B or type 2 metals. So if it's not in column 1, 2, or 3, you still have to use the stock system. But you would just name the polyatomic ion as it is on the chart. You don't worry about changing its name at all. You could have a polyatomic ion bonded to a nonmetal, a positive bonded to a negative. Again, you're still going to balance charges. It's treated just like any other ionic compound. You're going to name the polyatomic ion as it is in the chart, but just like before with a nonmetal, if you have a nonmetal ending, you put IDE on the end of it. You can also have a polyatomic ion bonded to a polyatomic ion. You name them both as they are on the chart, and a positive bonded to a negative, so you're just going to balance the charges. So we're following most of the same rules that we did, or that we've used for binary ionic compounds. We're just applying them to polyatomic ion compounds. So for example, Here is a metal, magnesium, bonded to a polyatomic ion, SO3. So my naming rules, I follow the same naming rules I had for the binary ones. I name the magnesium like normal, and I name the SO3 like it is on the periodic or like it is on the chart. It's sulfite. I'm not going to use the stock system here because magnesium is in column 1 or column 2, so I don't have to. The next one, sodium, it's a metal bonded to a polyatomic ion. Sodium's in column 1, so I would just name it sodium, and then phosphite, PO3. LiBrO3, well, lithium is a metal. BrO3 is a polyatomic ion. Lithium is in column 1, so lithium bromate. I name it just as it is on the chart. PbCO3, this is lead combined with carbonate. CO3 is a polyatomic ion. But lead is not in column 1, 2, or 3, so this is where I have to rely on the charge of carbonate, which is a 2- charge. I have 1 carbonate, so I know my lead has to be a lead 2+, so lead 2 carbonate. I just follow the same rules as I had for the binary compounds. The next one, magnesium, is a metal combined with ClO4. But I have 2 of the ClO4 groups. That's, as we learn how to write the formulas, you'll see why we have to use parentheses, because you have to group these 2 together. I just can't put a 2 after this. I have to put the parentheses in to group all of that together to show that I need 2 of that polyatomic ion. But magnesium is in column 1 or column 2, so magnesium perchlorate. This is a polyatomic ion bonded to a nonmetal. So NH4 is a polyatomic ion bonded to phosphorus. So instead of writing ammonium phosphorus, I change the ending of the phosphorus to IDE, and I have ammonium phosphide. So the same rules as before. When you're writing formulas for them, though, you use the name to write the formula. Remember to group the polyatomic ions together. Use parentheses if you need more than one of that group. You have to balance the charges between the positives and the negatives. And you want to keep the polyatomic ions grouped together. So leave room in your notes for these 6 examples, and we're going to do more examples in class, but leave room for these so that you can specifically write these down. If you want to try them now, go for it, and then we can compare how you did with how we're going to do, or with what we talk about in class, and we'll see if you understand how to do the polyatomic ion compounds. The biggest thing is going to be keeping them grouped together, just like on the previous slide here, where if I need 2 of this perchlorate group, of the ClO4 group, I have to put it in parentheses to show that I have 2 of that whole group, not just putting a 2 after it and saying I have 2 more of the 4 oxygen sets. The same thing here with the ammonium. I need 3 total ammoniums to balance out the phosphorus, which is why you have to put it in parentheses. So I want you to write a level 2 test question on the left side of your notes related to naming or writing formulas for the compounds that we covered in Objective 6, so the polyatomic ions. We will fill in the foldable in class for polyatomic ions, and we will work more examples as well as the other types on the whiteboards and in class. We're going to put it all together to where you're going to have packets that are going to have all the different types of compounds on it, and you're going to have to decipher which one is which. So there is some website practice that we're going to do in class as well. But for the most part, that's it for polyatomic ions.